All right, so factoring is just undoing multiplication. All right, we're going to find the greatest common factor quite a bit. Now, we're always looking for a greatest common factor first. We just abbreviate that, the GCF. All right, so steps are super easy. You'll find the greatest common factor, kind of first focusing on the numbers, and then find the variable GCF. There doesn't have to be both, but you're always looking for both. It's the common variable that is in all the terms and raised to the lowest power. So in all the terms and raised to the lowest power. And then you're going to rewrite each term so that it's GCF times whatever's left. Okay, so it will always be a product since we're undoing multiplication here. So the first 4 questions I think are going to seem ridiculously easy, which I hope is the case. Again, this is just a very simple review of Algebra 1, and then I'll kind of show you what it'll look more like in Algebra 2. So looking at 1, so we'll start with the numbers, 24, 12, and 6. What number do they all have in common? 6. A 6 goes into all of them. So I'm going to pull out a 6. And then I have an a squared, an a, and a cubed. What could I take out of all of them? Just an a. And again, it's the lowest power. I couldn't take an a cubed out of just an a, right? I have to take the lowest one out. So I can take out a 6a. So GCF in front. You can use parentheses, bracket. I apparently just drew a bracket, but parentheses are just fine. And then you're just undoing it. So 24 divided by 6 leaves me with 4. If I had a squared and I took out an a, I'm left with just an a. Then I have a plus sign. 12 divided by 6 is 2. A divided by a just ends up canceling out. Then I have a minus. 6 divided by 6 is just 1. I had a cubed. I took out an a. Therefore, I'm left with a squared. Okay, so literally just pulling out a GCF. Now, what's great about GCF is you can always check to see if you're right. If you multiply this back through, you've got to get what you started with. So 6 times 4 is 24. A times a is a squared. Check. 6a times 2 is 12a. Check. 6 times negative 1 is 6. A times a squared is a cubed. It's got to work. Okay. All right. Try number 2. So first check and see if there's a number they have in common and then a variable as well. Could you pull something out of each of those numbers and variable? Alistair? 3L. How do we feel about 3L? Feeling good? Yeah, that's great. So they're all divisible by 3, all the numbers, and they're all divisible by L. That's perfect. So again, if I take out the 3L, if I divide it out, what number should be left here? Cole, what are you getting? 5 and an L is perfect. So that's 15L squared. Perfect. The next one, I'm thinking 7. Does W squared sound right? And then plus, do we like 12H? 12H. Okay, and we just want to make sure that nothing else, that there's nothing left that's common between them, and we're done. And again, you could do a quick check, distribute back through, make sure you got what you started with. All right, try 3. I got to pick on a few papers here. I see some people writing down 3 and 9. Does 3 go into 16? No, so 3 cannot be a GCF. Does 9 go in? Well, does 9 go into 3? Oh, okay. I'm just checking. Is there a number GCF? No. Does it have to have a number? No, and that's okay. There is no number that they're all divisible by. How about variable-wise? What could we pull out? X? Can we go bigger than just y? Y squared, right? That would be the smallest in each one. I could definitely take out a y squared in each one. Okay, so just be careful with exponents. So obviously I still have 16. If I had x cubed and I took out 1x, then I would have x squared. Y squared took out y squared, so there's no y's. We didn't take any numbers out. There was an x squared, I took out an x, so there's still an x. Y squared took out y squared, that's gone. Plus 12, x took out the x, that's gone. Y cubed took out y squared, so I should just have a 1y there. Okay. And again, just a quick check. Say it again. Did I miss something? Oh. Did you say something? Oh. It's been a long weekend, guys. If I distribute through, I should get what I started with. All right, one last one until we get to the Algebra 2 ones. So take one more step there. Pull out the GCF, and then write what's left times what's left. And this one gets people sometimes. Don't fall for the trap. How many terms are there? So how many do you need in your answer? 3. You can't go from 3 terms to 2 terms. That can't happen because remember, you have to distribute back through. So what are we saying the GCF is? 3x is perfect. So 3 divided by 3 is 1. X squared took out an x. I should have just x. Minus 3 divided by 3 is 1. X divided by x cancels. I should have just a y. Now remember, we're dividing. There has to be something here. There was a plus sign. There has to be plus something. What number would just be sitting here? 1. 3x divided by 3x is 1. And again, if that wasn't there, then there's no possible way for me to get 3x at the end. I'd have to have a 1 there, okay? All right, so this is the Algebra 1, which will do a ton of GCF work. This is what it's going to look like in Algebra 2. It's still a GCF. You probably just haven't done them that look like this. All right, so I have it under more difficult. We are now pulling out a binomial GCF, which just means it's 2 terms instead of 1. So all I typically do when it looks like this is I'll bracket in up to the minus sign and after the minus sign. And I'm just looking to see what they have in common before and after either the plus or minus. What looks the exact same? Yes, and again, it's a binomial. It should be the binomial piece, the 2x minus 1. So the GCF is now a binomial of 2x minus 1. That is what we're taking out of both. Okay, so I'm going to put a bracket. So you can picture like me crossing off. If I take out 2x minus 1 here, what's left? 3x. Then a minus sign. And I took out the 2x minus 1. I divided that out, so I'm left with just a minus 4. Okay, and it should check out. 3x times 2x minus 1 is 3x times 2x minus 1. Minus 4, distribute, 2x minus 1. It should match up. The last thing I want to do is check to see that nobody else has a GCF. 2 and 1, no GCF. 3 and 4. I'm up, actually, we like to say FC for factored completely. Put a little FC there. And I'll just write it out once. That means it's factored completely. Factored completely. So as they get to be uglier like this, there's usually multiple factorings to do. All right, take a look at 6. Okay, again, it's ugly. I'm going to bracket in before the plus sign and after the plus sign. What do they have in common? Christian, your book is on Mrs. Rahill's desk. You must have, yeah. Found it this morning. Well, it was there. Is it on her desk? Okay. What binomial do we see they have in common? 2a plus b, so that's the GCF. So again, picture crossing it right off. You're taking out 2a plus b and 2a plus b. From the first term, you're just going to have 15x. And from the second term, 10y. Okay, now, you have to ask yourself every time, can any of these terms get factored again? Well, 2a plus b has nothing in common, but what do I notice about these? What do they have in common? A 5. So this has to get factored again. So I'm going to leave my 2a plus b. I have a GCF I can pull out. We just said we can pull out a 5. Okay, can't take out an x or a y, but they're both divisible by 5. So this will leave me with 3x plus 2y. And again, I'm going to put a little FC. It is now factored completely. Okay, and this is where they usually get you on the multiple choice. And like I say get you because they're sneaky. This will be option 1 every time, and the directions will say factor completely, and this will be option like 4. This is the one they're looking for because it has to get factored completely. All right, so you want to keep that self-talk. Make sure you've factored completely every time. All right, go ahead and try 7. And again, before the plus or minus, after the plus or minus, pull out the binomial GCF. Brayden, what are you pulling out? Perfect. 3y plus 1. Okay. And again, I'm going to picture like literally crossing it off. There's a minus sign, so there has to be 2 terms. In the first term, I'm left with just 4x. Then there's a minus. If I divided it out, I'm left with what number? 1. Okay, then don't assume you're done. Make sure you check. Can anything else get factored? No GCFs. So I'm going to make a little note. I'm factored completely. All right, let's try 8. So again, algebra 2 GCFs are going to look more like this. Looking for something that's the same on each side of the plus or minus sign. What can I take out? Perfect, 2x minus 3. So if I take this one out, I'm left with 4x. Then I clearly have a minus sign. Now 2x minus 3 squared just means you have how many of these? You have 2 of them, and you just took out 1, so you still have 2x minus 3. Now watch carefully how I wrote that, because again, most missed questions on our test still are about subtraction. Okay, so again, just to be clear, this squared means you have 2x minus 3 and 2x minus 3. We took out 1 of them, so we still have 1 left. All right, now notice I kept it in parentheses because what do I have to do with this minus sign? Distribute. So I'm going to leave my 2x minus 3. This is going to be 4x minus 2x plus 3. It's the same thing in long division. It's the same thing in subtracting problems. You have to distribute the negative. And then I'm going to clean it up one more step. So I have 2x minus 3. I have like terms in here. 4x minus 2x just becomes 2x plus 3. And then again, I want to check, can anything else get factored? I don't think so. Those don't have anything in common. So that is factored completely. All right, last one to tackle. So again, I'm looking on the left, looking on the right, looking for something they have in common, typically this binomial GCF. What is the smallest amount of x minus 2's we can take out? 2 squared. Yes, we can take 2 of them out of each. So again, x minus 2 cubed means I really have 3 of them. If I took 2 of them out, I'm left with how many? 1. So I'm just going to actually kill that 3 and make it a 1, so to speak, of one of them. And here I took 2 of them out, so this is gone. I took it out. So on this first term, I'm left with 5x times x minus 2. Then I have a plus sign, and over here I'm left with just a 3. So again, I had 3. I took out 2, so I'm left with 1. And then I just need to clean up. So I have x minus 2 squared. Can distribute this. Is that going to be 5x squared minus 10x plus 3? No GCFs. We haven't talked about this type of factoring yet, so we're not going to worry about it yet. We're just literally on GCF day. So we'll say that's factored completely. Okay, so be real cautious with these binomial GCFs. Just make sure everything is completely factored. Like I said, we're going to get a lot of practice in today. Our goal with factoring is always a lot of practice just because it's such a big part of algebra. It's going to look crazy, but we're going to go front and back, but we have 25 minutes, so nobody should walk out of here with homework is what I'm trying to say. You're going to work on this front and back. Check your answers as you go. Please don't just copy the answers. That doesn't help us at all. I'm going to spend a few minutes finishing these tests and get them back to you within the next 10 minutes is my goal. But start working on